Good afternoon, boys and girls, and welcome back to another math session. In this math session, we'll still be dealing with statistics, but we're going into the portion where we have to find the mean or the average. They're both the same. What the mean is. The mean is the sum of all data divided by the total numbers within a data set. What an outlier is, another key term there, a data value that's much greater or much less than the other values. It will affect the mean if included. At times you will have to find the mean when the outlier is included in the data set, and you'll have to find it again sometimes when you exclude it, mean not included within the data set. And what will it do to the actual mean? It will change your outcomes. All right, so I have a data set here displayed. I've already found the mean for it, but I just want to go over it really quick. So in this data set, a person has taken 6 tests. Within the 6 tests, they've scored these averages: an 80, an 85, an 80%, another 85%, a 75%, and finally another 75%. So you ask yourself, that's a total of 6 total tests. So this is over the span of 6 tests. So we scored those averages. Now, I just added these vertically, and I got these outcomes, and I'm going to find the totality of adding all 3 of those together. Now again, back to the mean, you add up all the numbers within a data set, and then you divide by the total amount of numbers that are included within the data set. So once you add these 3 numbers, you should get 480 divided by 6. Divided by 6 because there are 6 total tests we're talking about. We have 6 averages from 6 tests within a data set. Once you divide 480 by 6, you will get an outcome of 80%. So our average on these 6 tests combined, we average an 80% when we take a test based on these 6 tests we have taken so far. All right, now let's throw an outlier in there. Right now, we don't really have an outlier present. But let's say we score on the next test, we score 100%. It is an outlier because our main average is an 80% on our test. Now, if we add an 100% to this, our next test we take, our 80% here is going to deviate. It's not going to be 80% anymore. It's going to increase. I wouldn't say it's going to increase greatly, but it's going to jump from an 80% to a number roughly greater than 85%. Again, what an outlier does, it will affect the mean. So we no longer have a very low B. We will have a good high B now. Instead of an 80%, it's going to increase it. And we will have it'll probably be increased roughly around 85% to somewhere in 87%. All right, let's say you took that same test now and you scored a 40% opposed to 100%. All right, that 40% greatly here is greater in difference, is a greater difference than your mean right here, which is 80%. Therefore, your 80% is going to decrease greatly. It's going to go down. 80% to a 40%, that's a good deviation of 40%. So it's going to bring that 80% down. And we won't reflect we score an 80% on these 6 tests. It will be roughly a low C or even close to a D. So, all right, so that's how an outlier will necessarily affect a data set, which is going to affect the overall mean. If it's greater than the original numbers, it's going to bring it up. If it's much lesser in numbers, in the numbers that are included within the data set, it's going to bring it down. So that's how an outlier affects a data set when you're locating the mean. All right, and again, an outlier, it's a literal term. All the terms we've gone over so far in statistics are very literal. So outlier, it's going to lie outside of the data set. It may be greater or it may be lesser in value. All right, you guys have a great one. I will see you Tuesday morning. Have a good night and stay safe. Bye.